Welcome to Applied Hydraulics and Pneumatics. Today's topic is on pneumatics. So first let us see the properties of air. Air is a mixture of many gases, water vapors and dust particles. Air exerts pressure. Air has mass. Air occupies space. Air is colorless and odorless. Air is compressible fluid. So you can see that setup of pneumatic components, basic pneumatic components. So first you have an air compressor which compresses the air which is taken from atmosphere. Then it is sent to this air tank or air receiver. There you can find this drain valve. So that is if any water is collected at the bottom, when the air is cooled, there is any moisture present in the or water vapor present in this air, that may be settled at the bottom. So you can set the time based on that. Probably 1 hour or 2 hours. You can. This will be automatically operated, and the water will be drained out. Then to get this dry air, you have a air dryer. Air dryer. Then after to get 100% dry air, then you have an air filter. Once again, then after that it may be connected to. So once again this FRL unit. Then after that passing through this FRL unit, it may go to this valve, direction control valve. Then through that, after that, finally the air may be supplied to the actuator. The actuator actuates and it does some mechanical work. Air filters are used to remove the fine contaminants from air before allowing it to enter into pneumatic components like valves and actuators. Air pressure regulator regulates the pressure at output at a set constant value irrespective of pressure. Pneumatic system circuits, fundamental design consideration, safety of operation, performance of desired function, efficiency of operation and cost. In case of pneumatics, leakage and friction losses are most crucial design factors that affect the above parameters most. So pneumatic system include four basic working cells: air power source cell, air source pre-treatment, air control cells, air actuator cells. So pneumatic components, we have a pressure regulator and filter. So here you have a pneumatic direction control valve, includes air valve, solenoid valve, foot valve, mechanical valve, hand valve. Valves regulate, direct or control fluid flow by opening or closing. They are installed directly onto pipes or hoses and control the pressure, rate and amount of fluid as it moves through the system. Here you can see that air actuator is a linear actuator. They can produce 1000 kg of force or broad range of velocities. Besides, they can cycle at high speeds without overheating and stall without internal damage. Here you can see that. So this one cylinder, then you have a piston rod here. So you can see the pictorial view of pneumatic actuator. So let us see how this single acting cylinder operates. So it's a basic pneumatic system. So this is power from this one air from air receiver is allowed to pass through FRL unit, that is filter, regulator and lubrication unit. Then after that so through this flow control valve, so it may be allowed to move to this direction control valve. So by operating this push button, so you can says either connect or supply the air or disconnect the air. Okay, suppose if the button is pushed, what will happen? This will be connected to this one. Then air will be supplied here. Then it will try to compress. The piston will be moving this side. Then at the same time, this one is compressed. Spring is compressed. So when this one is released, what will happen? The air will be, so it will be exhausted out, exhaust to the atmosphere. So to compress the air, we have compressors. One is positive displacement compressors and dynamic compressors. So two types in the positive displacement, reciprocating and rotary. In under dynamic, you have centrifugal and axial. So in reciprocating compressors, you have single acting, double acting, and diaphragm type. Rotary compressors, you have lobe, liquid ring, screw, scroll, van pump. Sorry, van compressor. There are two basic type of air compressors: positive displacement and dynamic. Positive displacement type, a specified quantity of air is trapped in the compression chamber, and the volume which it occupies mechanically reduced, causing a corresponding rise in pressure prior to discharge. Rotary screw, vane, and reciprocating air compressors are the most common type of air positive displacement compressors found in small and medium sized industries. Reciprocating compressors or positive displacement air compressor that is similar to IC engine, that is internal combustion engine. The only difference is the absence of combustion gases for the piston to work. These have been these have a piston connected to the crankshaft reciprocating inside the cylinder. The suction and delivery valves are at the top of the compressor cylinder. There are three major types of reciprocating air compressor: single acting, double acting, and diaphragm type. Here you can see this typical two-stage compressors. Here, this one part one, flywheel rotates the crankshaft, transmitting reciprocating motion of the piston. Here you have crankshaft is there, so which gives drive to the this one, which helps to get the reciprocating motion. So here downward motion of the larger low pressure piston forces the valve open to draw in air. When the piston is moved downwards, what will happen? The air will be sucked inside. So after moving downwards, the valve will be closed. Say then once again the piston will start moving upwards. Low pressure piston squeezes air, creating the first stage of compression. So that is volume is reduced and the pressure is increased. Then through this outlet valve, it goes to second cylinder. The compressed air passes through the air-cooled intercooler. To minimize the work, we have an intercooler to reduce the temperature of air. Smaller high-pressure piston moves downward to draw the compressed air. So when it reaches here, then once again this air is drawn inside the cylinder with the help of another another piston, that is relatively smaller size piston, by moving downwards. Then once again the piston start moving upwards. Then it compresses air further and forces the outlet valve open. So once the outlet valve is open, the air is discharged from second stage cylinder. This is the typical multi-stage compressors, reciprocating compressors. So thank you very much for watching this video.